Hello, this is Mike at GameFromScratch, and welcome back to our ongoing closer look at game engine series. Today we're going to be taking a look at the Stencyl game engine. If you've not watched any of these in the past, the whole idea behind a closer look at is we're going to take a jump, a bit of a review, preview, and getting started tutorial, all bundled into one, where we take a quick look at a game engine to hopefully give you an impression if this is right or wrong for you. So you can get a good overview of what is being offered and make a decision if this is how you want to proceed. In addition to Stencyl, we've got probably over a dozen of these now, at least in text form on GameFromScratch.com, and a handful of them now in video format. This one also has a text blog post to go along with it. Look in the comments; you'll see a link to it on GameFromScratch for the corresponding text version if you prefer to read over listening to me yabber on. So anyways, today we're looking at Stencyl, and Stencyl is what you see in front of you. Actually, this is the main Stencyl UI as it's loaded. It's a very all-in-one integrated game development environment. And if I'm honest, right up front, Stencyl is not what I expected, and that's a good thing. It's greatly exceeded my expectations, and it's actually very useful for a very wide variety of developers with a very big caveat. So if you're looking at getting started in game development, Stencyl is great for you, but even if you're an experienced developer, it's very useful either for small games or for prototyping. It's a very surprisingly powerful development environment. So, a bit of a spoiler, but I'm really quite impressed with Stencyl. Now, that caveat though, Stencyl is basically for 2D games. More so, Stencyl is basically for tile-based 2D games. So if that does not fit the description, Stencyl may not in fact be the right solution for you. But it's definitely worth checking out, and as I said earlier, even if you're just going to use it as a prototyping tool, it's a great option. Now, the nice thing is, in running games from scratch, I get asked quite often, how should I get started? How should I get started? And my general advice recently has been Lua. If I was to lean one way or the other, I would often say that the Lua development environments, the various things like Love or Corona or used to be Moi and other Lua-based game engines, were one of the nicest beginning approaches for game developers. Now, of course, there are tools out there that are also a great choice, like Construct 2, Game Maker, RPG Maker, etc. I've actually did a post on this in the past for parents getting their kids started in game development. But where I struggled is you kind of have this dual approach of, do you want to get started in game development and get results right away, or are you interested in programming, actual getting behind the scenes and coding? Now, a lot of these game engines take that and abstract it away from you, and Stencyl is no exception, actually. It's a completely visual-based coding environment. So you work in this tool, everything is visual, as you will see. However, there is a coding element, and so it nicely bridges that gap between the people that just want to get started and want to see results in as easy a manner as possible, or the ones that want to go a little bit deeper, go behind the scenes and learn how to code. Well, nicely, Stencyl bridges those two worlds almost perfectly. So that's why Stencyl has really impressed me with how it works. So without any more yabbering on, let's actually jump in and take a look at Stencyl. Again, Stencyl happens, 99% of it is in this player. You can do your coding in an external editor, which we'll see later, but for the most part, this is the world of Stencyl. Now, Stencyl has an impressive number of tools packed away in behind this. Generally, you won't use Stencyl for creating your art assets. You'll use it to import them, import your audio, etc. But there are quite a few tools bundled in here. This is the starting point. This is where your various game projects are stored. I went ahead and I downloaded a sample Flappy Bird implementation from StencylForge. We'll talk about StencylForge a little bit later on. But let me just show you a basic game in Stencyl right away. So here we go. We've loaded up our project. This is our Flappy Birds clone, and it's split up into scenes. So the logical unit of Stencyl, the organizational unit, is scenes. So your title screen is a scene. Your main game interface is a scene. Your game over is a scene. You might have different approaches to your game. Those could be separate scenes. But the fundamental unit of Stencyl games are scene by scene. So you break your game up into various scenes. Now, it is potentially possible that you have a single scene, and that is your game, and that is totally and completely fine. So we've got 3 created right here, and we could add a new one just by clicking here. We'll show you a little bit of the from scratch behavior later on, so don't worry about that for now. And now I'm going to go into the things that are actually played. So the targeted platforms, I suppose, makes a lot more sense. And out of the box, free version of Stencyl supports Flash Player. I know it's a bit of a relic at this point, but it's quite handy in this case. Quick build, and there's a reason behind this. Is behind the scenes, Stencyl is built over top of the Haxe programming language and the OpenFL graphic libraries, and so it kind of supports pretty much the targets that they support. And right off the hop, Haxe and OpenFL sort of came from the world of Flash. So that's why you've got this as a target. So you can either play it as Flash in the browser or Flash in the standalone player. Those are your probably fastest to deploy, but don't worry, those are not your only options. But here's where the money gets involved with Stencyl. Stencyl is completely free for what you see right here with the Flash support. But what you do pay for is additional platform supports. First off, you have your, see, you can see the Pro feature. So you're out of the box, you get StencylForge deployment, arcade deployment, and for the web. So those are the free stuff. But if you want to deploy for the desktop platforms, being Windows, Mac, and Linux, I believe it's $99 a year. Also, mobile, iOS, Android, and then Xcode would be for a Mac deployment project. Those are also $99 a year. So depending on the platforms you're deploying for, there is a price tag attached to Stencyl. All your development work can be done completely and utterly free. The difference between platforms is almost non-existent, other than, of course, your input types available, etc. But if you want to deploy to Steam Store or Google App Store or the Mac App Store, sorry, the iOS App Store, you are going to have to pay. It'd be $99 anyways, depending on which platforms you're aiming at. So that is the pricing model here. In my opinion, that's actually a rather fair way to go about it. Your functionality is complete. Otherwise, it is just publishing that you're paying for. Alright, so with that out of the way, let's go ahead and just run our simple game. Just up here at test. So right here you pick which platform you want to build it for. As I said earlier, Flash is the fastest. And then we'll just click Test Game. And here's the building process. It's not the fastest, but it's not the slowest by any means. It's quite reasonable in my opinion. So there you go. There's our game is now built and running in the Flash player. And if you've played Flappy Bird before, you've got an idea. There. So that is basically the game. You got your beginning screen, your game itself, and then your end over screen. And they're broken into the 3 different scenes here. So that's the core of a game. And as I said earlier, I downloaded this guy from StencylForge, and we will look at that in time. Now let's look at a little bit of the editing process. We'll start with the title screen. So here is the title screen opened up in Stencyl. Now, right away, what you see here is the guts of Stencyl for editing a scene. Across the top here, the different tabs for the different properties that you could do for a scene. At the same time, there's the same kind of editor for actors with different sets of options up here. But this is the crux of it. This is where you assemble your scenes together. And as I said earlier, it is a 2D tile focused workflow. So what you see over here, you've got your different layers. So you can layer your scenes on top of it. It's an impressive editor for sure. I'll use it again in a demo slightly down the road. You got your tiles right here and your different tile sets right here. Of course, there's only one here, and here are the tiles within it. And then over here, you paint them into your scene. You have your property windows over here. There's none particular to this particular scene. And then you have your editing tools. You can flood fill to fill a massive space with a single tile. You can go into draw mode to draw one tile at a time. And then you have other options over here, such as the ability to insert rows and columns of tiles all at once. There. Add hinged joints for physics. Add regions. Add terrain. And zoom in and out. So this is your basic editing zone. And your world, it's quite simple in a way. Your world is going to be composed pretty much of tiles arranged in layers, like so. And then your layers even have options here. So you can have how the blend mode works between the different layers. The amount to scroll by, have custom parallax scrolling, etc. So you do have some control over the way the different layers interact. But you basically just assemble your game out of a bunch of tiles, just like you would if you've used Tile Editor or TileEd. This is a very intuitive and quick workflow for making a 2D game. And you just basically assemble it this way. Now, you can set tile properties, we'll see that shortly, and then the next thing you do is add actors to the world. And here is the list of actors created in this game, your various pipes, your bird itself, and we'll look at actors in a second. And those are the 2 key building blocks, basically, of Stencyl. You have your scenes, and you have your actors. Your actors are things that do stuff in your scene, and your scene, obviously, is the world itself. Now, the world is a little bit misleading because this title, that was the title scene, so that was just a UI on top. And you see over here, these are the basic components that you can use to build your world. So your different actors are here, and we can easily create new actors, edit existing ones from this interface. Backgrounds are like the graphics you saw being drawn as one big block. You have font supports, your various scenes, which we saw earlier, audio support, and then your tile sets. So you saw the world editor right here, and I'll actually load up the actual level. This one's being procedurally generated, so you're not actually, in some ways it's a bad example. So you know what, I'll actually show that later on. We'll do it from scratch. So I'll come back and I'll show you drawing a level in a little bit. So just know that this is how it's done. It's being done with background images for one big image, and then tile sets drawn on top, and then you place your actors, which are the entities in your world. Now the next up we have are your behaviors and events. These two are essentially how you program in Stencyl. So they're very critical, very key, so I'm going to just completely ignore them for now. Next up we have physics. Again, what you're looking at right here is the physics for that individual scene. So these are just settings on the scene. So when we look at actors later on and see the physics category, it's going to have completely different options. Here really all we have is how your gravity is being applied horizontally and vertically. So, which is to say, there's 120 units of gravity pulling you down. Next up, you have atlases. Atlases is a bit of an advanced concept. We won't really get into it right here, but it's the same thing as, say, like a sprite sheet. It's a way of bundling resources together into a single large file. It's an optimization trick, basically. But you can build them there. And then finally, you have properties. This is the same stuff that you'd set when you initially create your scene. Your background transparency color, the size of your tiles, the width and height of tiles to compose your initial scene, and the scene's name itself. And that is essentially it. Of course, there's just behaviors and events, which I will get back to it. And then the other part that made up your world was your actors. So I'll pick up, this is the main character. This is the bird actor. We will create one of these from scratch as well, so don't worry too much about how this works. But every single actor has, even if it doesn't use, it has an animation attached to it with one or more frame. Like this guy. I ran into a situation, I don't actually know what the proper way of doing this is, but I created a 0-frame actor that was programmatically generated text, and it's totally fine. So even though it's requiring you to draw frames, I don't believe it's a necessity. I just used code to toggle off the visibility and then did everything programmatically, and it was completely a valid option. But this is the appearance of your guy, and you can have multiple animations. We'll also look at this in a little bit more detail, so don't worry about it too much for now. You have your behaviors and events. I'm going to skip over those again because that is the programming interface. That's what we're going to go to once we're done here. You have your collisions here, which are very nice. Basically, you can define your bounding volumes for physics. You could do it with polygons to make it more precise. This, by default, is using a box. But basically, this is the collision volume that will be used for your sprite. Now, one of the downsides to Stencyl, as far as I've seen, is there is one collision volume per animation, which is kind of annoying because if your sprite's dimensions change as part of the animation itself, the bounding box will only be good for the one it is configured for. So you want your animations to basically stay the same size, or you're going to have to split it into multiple animations and do the bounding volumes accordingly. Hopefully this is something they fix in the future so that you can set a bounding volume per frame in the animation sequence. And it's possible that you can do that. I just don't actually know the way. But that is one of the limitations I've certainly seen in Stencyl, unfortunately. Next up, you got your physics category. And this is actually really impressive. Physics is a complicated subject. It's full of terms and terminology that a beginning game developer is going to struggle with. Restitution. I'm trying to remember, they're not even coming to me right now. But basically, there are a number of properties that you can configure in a physical object for a simulation. And this is probably the most user-friendly approach to that I've ever seen. Now, you have pretty much all of the particulars that you would ever configure. They're just done in a logical way. So here's your straightforward stuff. And you basically say, this is a physical actor, or it doesn't move, or it's static in the scene, such as a platform. So translated elsewhere, this would probably be the same thing as static, kinematic, dynamic, but it can trigger this easy answered question point form list. Can it be rotated or not? Is it affected by gravity or not? But then you look over here, you got these other tabs that basically you can say the weight and angular mass of the object. You can set materials for the friction and bounciness, so you can predefine stuff like super ball or ice or wood, and then they will configure these values for you. So you can have a very consistent approach to these particular values. Dampening, and then finally your advanced settings for your physics objects. As I said earlier, this is probably the most user-friendly and intuitive approach I have yet seen to configuring physics. So kudos to them on making this so approachable and still having pretty much most of the settings you would use in a 2D physics simulation. And then finally, we've got our properties of our actor, and they can be applied into different groups. Groups are mostly the same thing as a collision group. That's handy for determining what can collide with what. So if you're in one collision group and you've configured it so that this group only collides with that group, this is where that group is being applied. So you have you could create a group basically called bullets, and a bullet may say collide with other actors but not other bullets, and that's how it's done. And this is actually in the is it settings? Yeah. So here you've got your different groups defined. And another nice thing with Stencyl, and you'll see it quite consistently through, so you might have a bit of confusion over what we're actually setting here with groups. Like, this is a little ambiguous. The interface makes sense. So you basically can see the floor group collides with players and actors. Makes sense. Doesn't collide with tiles and floor. Makes sense as well. But you could look at this and go, okay, I have no idea what I'm doing here. The nice thing is, how do groups work? You got the buttons like this consistently through the interface, where if you're configuring something and you don't know what to do, a lot of times there actually is a help button, and you just go ahead and click that, and it will bring you to the appropriate online help. Very nice, especially for a beginner level developer. So again, part of why I can easily recommend Stencyl to new beginners is they've done a good job of making the interface approachable and making help easily accessible when the interface might be a bit confusing. So while we're here in this settings, you can see a couple of the other things. You can see web-specific settings, mobile-specific settings, quite a few, splitting up into tasks, desktop-specific settings, your loader, your engine-level attributes, I believe, your control mapping. So when you define events and such, this is a way of abstracting the controls basically away. So you could have move up be the same as pressing the W key, hitting a virtual controller up, hitting an actual controller up, or touching a certain location, etc. So this is where you map your controls to the various. So there's up, named jump, and the key is up. And I can sit here and I could add another one, and then input the key as A, etc. So, and then again, if you have help, requirements, just go ahead and click it, and it brings you to the appropriate controller. Documentation. So they've done a good job that way. We're back to groups, and then atlases, which we briefly saw earlier, and then extensions. Extensions are very cool. They're kind of in their infancy, so there's not. I believe there is more extensibility being added to the Stencyl editor, but as it is, you can actually expand the editor itself. You can write code natively if you wish. There's full documentation on doing this, and you can basically extend the functionality of Stencyl, the editor itself. And as you can see, these are the ones that are currently implemented. So and you can go ahead and get more extensions in the market. So if you want to add dialog class, you can go ahead and add this, and just download and then enable it, and then now your Stencyl IDE is extended to have this dialog extension now included, etc. So nice, good extensibility being added, but I believe they're making the hooks a little bit deeper as time goes on, so I think that functionality will actually improve over time. So that's the different properties for an actor. So we've seen a scene and an actor, and basically those are the building blocks for your game. That is the crux of how you will actually make things. Now let's get rid of all of that. Let's get rid of this. Actually, you know what? They're going to have better coding, more complete coding than I'm going to show you. So let's go back into Birdie, and we'll go back into those behaviors and events. So events are the most self-evident, and ironically there are none. So maybe we'll bring a scene up to show that. And actors and scenes both have behaviors and events, but those are different things. There's scene events, and then there's actor events. An actor event is, again, an entity in the world, and these are basically things that can happen to it. So you can respond to the events here, and then behaviors are things like functions, reusable code for things this guy can do. And you can see they've defined a couple down here on the side. So behaviors that have been applied to this particular bird, it's called birdie. So this particular actor, sorry, are bird leaves scene, emit particles, kill platform, rotate bird, tap to fly. So we'll use tap to fly. That's what we were actually doing to keep our bird in the air. So this is one of the behaviors that have been applied to this particular bird. And back here, let's go to tap to fly, and we will look at the coding experience. Come on. There you go. Very simple. What you can see, and again, events come into click. So behaviors can respond to events like you're seeing here, and it is actually responding to a pair of events. The first one is click, and the second one is keyboard. And on click, it will play the swoosh sound, and then set the velocity of our self. That's it. On keyboard, same deal. And that is the basics of how programming work. We'll come back into this. We'll look into this a little bit deeper in a bit. But you're building these blocks of code that respond to different events. And you see, I can go here and go add event. And there's a number of different events available in the world. If you're coming from a traditional game programming background, here's your game loop, or your game life cycle right here is under your basics. So here's your on create, on draw, and on update. Or this is your game tick, basically. So your game loop is on draw, on update. On update, on draw, on update, on draw, on update, on draw. So if you want to do something on a frame-by-frame basis, it's done here. If you want to do something on initialization, it's done here. But there are other events available as well. You can respond to input events like keyboard, focus. Remember those regions we saw earlier where you could define? You could do it on enter of those regions for mouse or touch events. And then you've got multi-touch and swipe events available, and then gamepad. I'm making the gamepad gesture in my hands. That's not very useful to you. But there are gamepad events being handled as well. Plus, you could do timer-based events and game paused event. And then you have particular actor ones, so created or dies, enters or leaves the scenes, or enters or leaves a region. Your collisions, so you can have an event fire when something else hits you, or something from a specific group hits you, or something from a specific group hits another group, etc. You can have when sound is done playing or a channel is done playing, mobile specific events, so on purchases, ads, game center, or keyboard events. Then finally, you got some of the slightly more advanced stuff, so your own custom code blocks, etc. We'll leave that. I actually won't be going into that at all, to be honest. So, but here is your basic building blocks. You work by building, literally these are called blocks, but blocks of code. So first off, when you make your events, we'll add a brand new one, add, and then we'll do an on create. So it creates a new block of code to be called when create is called. And then over here, you've got other blocks that you can compose. So we'll do an if. So all of a sudden say if, and then something goes in this if block. So the block inside will be if this if evaluation is true. So and then you put the conditional inside, and this is very stupid, but if 1 is less than 2, then if this condition is true, whatever the code is inside of this block will fire. Now we're attached to an actor right now. We're in an we're in actor specific behavior. So what we're going to do is we'll go ahead and use the actor right here, and this gives us the availability of self. Whereas if we were in a scene, we could actually pick the actual actor that we want to do. So let's just say x of actor. Oh, that's actually just returning a value. Let's set the x location of our actor to 0 for self. And so we can set the x or y. So here is a very simple example of, so when the game starts, and then a really stupid if condition, but this could obviously be a much more involved or useful actual if player count is greater than 2 or whatever. Like it could be a much more logical condition for this block. Then it'll go ahead and run this code. That's it. This is programming in Stencyl. It's very intuitive. You have a number of different attributes here. So like go back to flow. We have our conditions. So ifs, your booleans, your comparison operators. Then you got your loops here. So definite loop, indefinite loop, and your break continue type logic, time-based, your debugging commands. Now here's one area that Stencyl sucks at. The debugging is pretty much non-existent. Unfortunately, so there's no way to set breakpoints right now. You can't do watches or expressions, etc. So most of your debugging will actually be done as a combination of print. So you could come in here and say print some debug message like so, and then when you run your game, that will log out here to this log viewer. So that's kind of it for debugging right now, which is unfortunate. Now, however, you can debug a game externally, which we will see in a second. Not the debugging part, but the external part, which is very nice. So I'm just going to go ahead and delete it. Actually, I need to... Was it created that I added? All right, so let's go ahead and just delete that whole thing. So that is your programming interface. So you have your events, which are things to respond to, game loop, something happened in the event, or you can actually broadcast an event, which is trigger event, and name it yourself, and you can trigger it for the scene, or you can trigger it just basically for the world to see, and then you can have an on event handler. So you could create an event called main character died, and then handle it. Anything can grab the on main character died events and do whatever accordingly. So there's a nice communication system already built in. And then the final thing that we've got, other than these blocks to work with, events and why is my brain not working all of a sudden? Sorry, events and behaviors. You've got, let's get back where I was. Here we go. All right, tap to fly. You have attributes. And so these are the behaviors to work with attributes. So get, text from, or set. But attributes right here, an attribute is essentially a variable. So you could say my at and give it a type, like so. So this is your variables. If you come from a traditional game programming past, or say you're a C++ programmer or something similar, you can sort of think, events are events, things like delegates or callbacks type of equivalent. That's what your event is. Your behavior is sort of a cross between function and the object. They're kind of rubbed into one. And then these are your members, your member variables of your behavior. Now, one thing that's key to understand here, though, I'll just shut this down. The saving is a little slow. And another thing I'm not liking with Stencyl is there's no ability to do just save current edit, which I don't really understand. There's save game, and that's it. So I don't know how to just save one thing, and I think it makes some of the loading a bit slow with that functionality. So anyways, as I was saying earlier, the behaviors are actually decoupled. So an actor isn't really a class in that its methods aren't necessarily part of it. So let's look right here. So see, you got these actor behaviors, and a lot of these are you can get predefined ones that are built right into Stencyl itself, or you can define your own, like what you see here. And we looked at one earlier. There was the tap to fly behavior. So these can actually be applied to any actor. So they're functions that apply to all actors, not necessarily a specific instance. So behaviors are reusable. Ditto on scenes. Scenes can have their own behaviors, like you see, switch scene on click or touch. For example, this is actually applied. So you work on your scene, and you add, so if we open the scene up, you go ahead, and then when you want that behavior in, you click and say, I want to add this behavior to this scene, like so. And then you can set the various properties of that. So your behaviors for actors and for scenes are reusable on numerous actors or numerous scenes. Make sense? Hopefully that did. So the last thing, though, and here's why Stencyl is so easy to recommend to people. First off, I think this is intuitive. I think this, especially with the integrated help as you go through things. Oh, and I didn't even show you that for, so let's bring back that tap to fly. Come on. Oh, edit. Okay, so while you're sitting here and working on this guy, so say I have one of these attributes here in my palette, like this guy, actor is on screen, and I don't know exactly what this does, just right click it. And you can do view help. Ditto over here. So the set velocity to blah, 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 blah for self, or play the sound, just right click it, view help. And it brings you to the help for that particular brick. Again, the accessibility of help is very critical to a new developer. So I really appreciate that. I think it's very well done, very consistent throughout. Now, why I recommend Stencyl beyond new developers, other than the fact that I do think this workflow is very intuitive. I do think the level experience, the level editor is very well done. I think it is actually one of the best 2D level editors out there. So that's an impressive accomplishment to start with. And I also think that a lot of times an engine like Unity or Unreal, these big gigantic 3D engines that are repurposed for 2D, are just so overkill for a lot of 2D games, that having something that works well and works intuitively, even if it's not the most advanced thing you've ever seen or possibly the fastest thing you've ever seen, it's still often a better fit. However, for the more advanced developer or for the beginner that wants to sort of grow out their abilities, here is where Stencyl absolutely shines. See this preview code? Stencyl is ultimately a code generator. As you're building these behaviors, your attributes, etc., you're actually building Haxe-based classes behind the scenes. So this particular behavior, this tap to fly, is creating this code. So it's created a mouse press listener that when it's called is doing a play sound and set velocity. So see this play sounds, the set velocity? Play sound, set velocity. So this brick is really an interface over top of code like this. And that is awesome. So you can actually edit this code. You can create Haxe-based code of your project. You don't even need to use any of the rest of the stuff. You could do it entirely in Haxe if you wanted. And what's also kind of nice there, and on GameFromScratch.com and on the text version, there's a link to this. You can work in your editor of choice. I like IntelliJ. IntelliJ has nice Haxe integration, and it's cross-platform, which is critical here. It's got, you can have your code, basically, you can say edit externally, and you can now edit this code directly in your IDE of choice, which also means you can now debug your code as a Haxe project line by line. So for the more advanced developer who needs to add this functionality, it is there. And the best part is all of this stuff, so these Stencyl extensions, etc., they're documented. Let me just, I'm not sure if there's no context help here. So if you create your own, if you're creating your own behaviors, etc., or and such, you can always go and edit it. There is their own integrated code editor, but there is also, like I said, the ability to go off into your own version. And when you got it set up right, you actually still get full code suggestions, code completion, IntelliSense, that kind of stuff. So let me just pull up Stencyl and show you help, Stencylpedia. So there are two sets of help for Stencyl. One is this Stencylpedia, which is sort of your introductory level stuff. That's where your walkthroughs are, your blocks, your getting started. And right here is your full guide. This is probably where you'd want to come in. And this is more or less a walkthrough of Stencyl's higher level interface. Very useful, well done, well written, pretty much all up to date. So that part is good. The documentation that is attached to Stencyl is very good, which is a key thing in my opinion. And then finally you got this developer center, which is for your more advanced developer that actually is going to be working in Haxe. If you've never heard of it, Haxe is it's an action script inspired language. It's transcended that. There have been a number of commercial games actually released that were written in Haxe, but one of the big things about Haxe is basically it's a code generating kind of programming language. So you write something in Haxe and you can say, all right, now generate me the action script version, so the Flash version, or generate me a C++ version. So that C++ version can then be run natively on various different platforms, etc. And that's essentially what Stencyl is using for its code generator. So it's sort of Stencyl, this visual language, is a code generating language for Haxe code, which we saw briefly a second ago, which in turn Haxe then can generate CPP code, which can run natively on various platforms, or it can create Flash code, etc. So Haxe is sort of this meta language that generates programming code in different, or it creates language for its own virtual machine, or its own Haxe binaries type thing. But that is the kind of the idea behind Haxe. Haxe is kind of cross-platform by generating code for the various different platforms that it needs, which you can then compile and make native. So we've got this documentation here for working in Haxe. And that means here's the Stencyl API. So if you're working entirely in code, It's well documented. Here, basically, this is your class reference of the various Haxe Stencil API. A lot of this is linked in. So, like Box2D is an existing library. The Flash libraries, Lime, OpenFL, etc. Those are really underlying graphics libraries that Haxe itself relies on, but they're available to you as a coder. And then on top of that, they have their own set of extensions that they've had it here. For example, your behaviors. These guys right here. So here's your behavior class documented. You've got actors, which I believe are under models. Actor. So everything you're seeing on the one is also exposed in code behind the scenes. So you can create full Stencyl games. Basically, you go into Stencyl, you could do your level design, I guess, if you wanted to, using their existing tools, but do all of your coding, all of your logic, everything in Haxe, in either Flash Develop or IntelliJ or whatever editor you wish to use, or you can use their integrated editor as well. Now, if I loop back here, there's also code here for doing extensions. Extensions are done, I believe, in Java programming, to be honest, because Stencyl itself is ultimately a Java application. But you've got these options for basically building plugins, extensions, and they've got sample games as well. And there's also the extensions market, which we saw briefly earlier, so you can add extensions to your game. So you can build extensions with Haxe, which would be here. This is showing you the various callbacks and things you can handle for creating new extensions. And they, like on Stencyl Startup, on a game open. So there are a couple of hooks in. I believe they are adding more. So you can extend Stencyl itself. You can work at the native level, so you could create your own. Right at this level, you could do your own Haxe classes. You could, if you didn't want to use Box2D, you wanted to use a different physics library, you could do that yourself natively. And also, there's another aspect of it, way beyond what we're going to talk about here, but you can also add native extensions. So if you had C++ code you needed to run on iOS, you can implement it behind the scenes. It's part of where these extensions are actually flagged as compatible with X devices. So it is well documented. There is everything you need here, but you don't need to touch any of this stuff. If you're just beginning, you could stick to the Stencipedia. You don't have to touch code at all. All of this code is there in case you hit a brick wall and want to move beyond, or you prefer working in a code-like environment. I normally prefer working in a code-like environment, but to be honest, I didn't mind working with bricks. It felt like programming. And when you saw the code it generated versus the code you worked with, this code here versus this code here, they're very similar. Like it's a very close one-to-one type relationship. So that's a big part of why Stencyl is so impressive to me. If you are looking for more flexibility, if you want to work as a coder and you don't want this visible stuff, that's your option. If you're a beginner just starting out, and you like this visual stuff, this is great for you. This should make sense, I hope, as a way to visualize program flow. Now, if you do want to get more advanced later, or you want to understand what it's doing behind the scenes, it's a button away. And that's just awesome. That's a very, very cool feature. So highly recommend. Stencyl might actually be my go-to recommendation for new developers looking to get started. And this is why. The great integration of help. The all-in-one tooling system. And as you saw, two different ways of programming, both of which are pretty solid. So that's kind of it. Now, I'm going to show you one thing very quick. We'll start from the beginning. So you can see I'm using an existing project that we saw here. Actually, before I go, I'll actually show you how I got it. And I grabbed it off of StencylForge. And this is another thing that's critical, in my opinion, for a beginner just starting out, is you need assets to work with. So if you start with a notepad open and you want to write a game, you need to somehow come up with a graphics library to use, programming language to work in, the assets to work with, sound effects to go with, etc. This kind of makes a lot of the stuff available for you. So this is StencylForge. It's integrated directly in, and here are the various things that you can get. So let's say, for example, I want to get an actor. I come in here, and there's a number of pre-made actors in here. So if I wanted these bananas, I can come in, double-click, and I have now added download, and I can add bananas now to my game. It's that simple. It's that integrated. Or if I just need even full games to work with, you can come in here, and this is where I got the Flappy there. So sample games can be downloaded right from this StencylForge. Same with tile sets and sound effects, and pre-configured fonts and backgrounds. So when you need materials to just get going, they're here. They're in StencylForge, and as of right now, at least, as far as I know, there's no cost. There's no actual. It's called a store, but it is not a store. There's no price or marketplace attached yet, anyways. So this can all just be downloaded and immediately used in your game. So if you're just starting out, it's awesome to have this stuff at your fingertips right away. So another big thing that I'm impressed by. Ditto for behaviors. If you need to add code or logic to your actors or scenes, right here you can see here's logic for handling a door. Attach this behavior to an exit door to detect player collisions, as an example. Or I believe there's even there's another one I was thinking to show earlier, but so you can get pre-programmed behaviors that other people have shared, or you can come right here into the extensions. No, it wasn't extensions. Where the heck was it? I know somewhere in here there's an A-star implementation, which is a pathfinding algorithm. You just download it and use it. I thought it was an extension, but I might be blind. So anyways, this StencylForge is for someone that's just starting out, looking for assets to play around with or work with. It's just this matter of pick one and download it, and then it is now part of your local resources, and you can add them in. Now, as I said, we're going to start from scratch very quickly, and I'm going to show you the creation of an asset and creation of a level, so you have an idea of just how fast these workflows can actually be. So I'm not going to save that. Let's just fire up another instance of Stencyl. Now, there are a couple flaws with Stencyl. Again, it was written on Java. One of the downsides is Java has a heap variable, so on occasion you might run into this error message that says 90% of your memory is used. There are ways of fixing it, but it is an annoying message that you are going to run into. Another thing I have found is on occasion things just get stuck. You get an error message that it will never go away, and you just basically have to exit and come back in. It's an annoyance. It doesn't happen that often, but there are some flaws in here for sure. Okay, so we're going to come in, we're going to create a brand new game from scratch, so you can see the entire process. So we're creating a brand new game. So once again, there's this nice integration. You can come on back and get one of the sample kits to start with. But we're just going to create our own demo game 42. You set your width and height. It will automatically do the scaling for you for multi-resolution devices, but let's just jump in with the defaults. All right, so we have a brand new game with no scenes. As I said, scenes are basically the building blocks of your world. Your game is going to have at least one scene, which you'll set as the starting scene, as down here, and then you have actors that populate your scene. So first, let's go ahead and we'll create a scene. So make a new one, and we'll call it My Game Scene. So set its initial default width, height. As you saw earlier, this is actually available as the properties later on, so these all can be edited. So we just created a new scene for our game, and it'll immediately bring us back to our level editor. Let's go back to our dashboard for a second. Now I'm going to want to go ahead and make a tile set so we can paint our scene. So there are no tile sets. Click here to create one. Same process. Or you can come up here and create one that way. So we will call this My Tile Set. Go ahead and create that. Choose the image you wish to use for your tile set. I have a couple from actually the Humble Bundle that's going on right now. That's kind of key. As of right now, it is July the 20th, and there is a Humble Bundle for sale that includes a year of pro license for Stencyl and the assets I'm about to use to make this example. So if this does look interesting to you and you are watching it pretty much right now as I create it, go check out humblebundle.com and you can pick this all up for like $12 with a bunch of other game tools as well. So it's a nice opportunity anyways. So here you go. You got your default level just created. Your tile is 32 by 32. You can see 32 by 32. You could obviously change it here. If you have a transparency color, you could set it with your masking color. I don't need to. Don't need to resize it or anything. That's it. So I just created our very first tile sheet, and let's add that sucker in. So now we have our tile sheet. Now what you see over here, so you've got the ability to actually pick your tiles, and let's say this guy. This is going to be our generic background tile, this guy at 7A. I'm just going to say no collisions on this. But here's where you can set your various values for your tile. And what's even more cool, and I don't have a sprite to illustrate. Here, I can show you with this guy, actually. So grab this guy. And so there's these two lavas right here. Let's say I wanted to make an animation with our tiles. I can actually, let's see, how do I add the frame? Import frame. All right, ignore that. Won't show it here. I'm doing a very bad job of it. But you can create animated tiles and set the speed between the frames. I don't have an image to import, but so if you had a pulsing lava in the background or a torch flickering on the wall, etc., you can easily bring your frames in and set them right here. Next up right here is you've got your predefined bounding volumes. So these are your simple shapes. So if you had it so that the character could not walk through the core of this guy, you pick the one that fits the best. Now, if I'm looking through this list, none of them work really well. So we're just going to go ahead and add a collision volume. So we'll create a polygon. And here's your default. It's got these three. This interface is not the greatest, but it's nicely integrated. So here we go. We're going creating our bounding volume. And as it says here, define points in counterclockwise order, this way. So we're going to be adding points to the scene. And I just added one right there. And we'll add one more right there. That's probably enough. So this is our collision volume for, collisions. And created, add that. So now that is the collision volume for this particular column. And then finally you can sit here and go, this tile is lava. So this is code pullable metadata attached to that particular tile. And you can do this for each and every tile in the tile set. Of course, you don't have to. And you can also set all of them at once. So if you had no collisions, you just come on here and go, bang, no collision, and they're set. So very nicely integrated tools for handling your tile sets. And that was creating of a tile set. Nothing magical about properties. So once you've got your tile set set, see there's this asterisk here that I've made changes, but there's no ability to just save that one asset, which is kind of infuriating. So if I want to get rid of that, I'm going to save everything, which is really stupid. So anyways, my tile set was automatically imported for some reason. Maybe it's because it's the only one. And now, so I'm in my scene, in scene editing mode with my tile set loaded. And you can have multiple tile sets attached if you wish. And you can also, again, make multiple layers. So I'll just go ahead and grab that tile right there, the one that I set no collision volume for. Go over to flood fill here and just fill our world with it. And next, it's just a matter of grab the shape you want and in paint mode, and then you just paint. Like so. If you want to have layers on top, add a layer, draw on it, decide how they're going to blend together, if it's visible or not. Or what's nice, so say I want to paint that section of tile, I just select it in a volume shape like this and paint. I want to do some of these, same deal. So creating levels is exceedingly simple, very cool that way. Now let's look quickly at actors. So there was a scene, and what you do, you just basically draw your particular scenes like this, like we just saw with this tile set creation. And there's our main scene. If I run the game, it should immediately come to that scene. There you go. So there is our gameplay. There is the scene we just created. Very easy. Now let's go on back to our dashboard, actors, and create a new actor. We shall call him my actor. I will call it actor. Okay, like so. So by default, no animations attached to this actor. Let's go ahead and create some. I already have a couple that I'm going to go with. So first off, let's create this first animation. Like so. All right, why did you not? All right. So I've predefined these. I'll show you quickly in Explorer what I've created. So I've rendered out these sprite sheets from Blender. All right, what are you doing, computer? There's one of them. Basically, it's a jump sequence made out of these individual frames, like you see here, and then a run sequence made out of these particular frames you see here. Now, I was stupid when I created it, and I forgot to set the transparency, so I have a full color, but I can show you color masking as a result. So all I do is go in now and I'll load that file. So that's under C temp. So we'll do run first. I just know 11 columns, 2 rows, no spacing between them, so they're consistent. So here's each frame as it will be created, like so. And I now need to set a masking color, so just click that, and then you're basically telling it what color is going to be the background color. If you brought in a transparent PNG or transparent image, that would not be required. So anyways, there is our running animation. You can see it already in effect for our sprite right there. Now let's give that a better name of run. It's looping, origin point, so this is where to draw it relative to, and we'll keep it in the center. And then next up is you could set the collision volume for this guy. This interface is a little awkward. I find I have to set the position first, and then I can edit it, which makes no sense to me. Okay, so I will set it to 128. And I will set this to say 96, like so. And now I should, come on. Like that. So there is our bounding volume for our sprite being defined-ish. Alright, so that's good. Let's head on back to appearance. And if you had multiple animations, it's just a matter of add your other one. So in this case, jump. See, there is the error message. You can increase the heap size. Actually, I ran into some problems doing it personally. So I also find you can generally ignore that message once you get it. And that's more Java related than Stencil related. But it is an annoyance. Hopefully it's something they can figure out a way around. So, oh, already did run. Jump. So, I'm not going to set its collision volumes because I'm not actually going to be using this guy. But there, so you now have two animations for my actor. And you can see each one is a tenth of a second in duration. You could multiply select them like so. And then, oops. That's not what I wanted. Come on. Oh, come on. Swore you could. But you can select it and change its duration in milliseconds. So if you wanted this frame to last a full second, you can set it to 1,000, etc. I'm actually going to leave them because I do like the idea of that particular speed for this animation sequence. But it can be edited that way. Why am I wrong here? I swore I could do that. Try one last time. There we go. So we're setting them all. So if we want to make this animation like twice as slow, so now they all have 200 millisecond. And you'll see he now jumps really slow. Whereas I can come up here now and say, make it more like 50 milliseconds. He now jumps very fast. But you can see the results up here in real time. Now, we've got our run actor already created. Let's go back to our game scene. And so far we've just used tiles. But now if we had to add a character to our world, just a matter of select it here, put it somewhere in the world like so, and done. If you want to see animations, you can turn it on like that. We'll go ahead and play your game. You will have now your actors placed in your scene and off and running. Come on. Alright, there you go. So there is adding an actor to a scene that you created in literally seconds. Now on top of that, you want to probably start adding some abilities to this actor. Now, let's do that very quickly. So my actor, let's go to the behaviors. We'll add a behavior. We'll use one of the built-in. So you can see there's a number of built-in behaviors you can work from. So explode on death, follow the camera, make a switch scene button, etc., etc. Of course, you can build these yourself, and each behavior will have a set of configurations for it, but I'm just going to do this simple back and forth horizontal movement. And here you can see the settings. You can say how fast to move by, initial direction to start with, so we'll start by left, and we'll go up to 500 left, 500 right, which is actually bigger than our scene, and change direction on collision. And done. So now we go back to our game scene. Should save everything, and now our actor will have some behavior. I have a collision volume that I'm running into. Okay. Was not expecting that. Alright, let's go back to my tile set. Set everything to no. My actor, his physics are set to normal. Can't rotate. Not affected. Alright. Let's try that again. There you go. So he's going to run, and he's going to get to 500, I think it was, and he's going to run the other way. Now, there's a lack of logic here on that he doesn't flip. And if you actually go to the GameFromScratch.com version, the blog post of this, I actually implement a very simple behavior that flips the sprite based off which direction you're going. So if you actually want to see how to fix that, it's available there. But I'm running a bit long as it is. But I just wanted to show you how simple it is actually to put all these tools together and make things work. And that's essentially it. There's a bunch more. Here's your integration again to your help, to your add-ons available. You can add extensions. Your debugging, again, is really limited. It's mostly a matter of log files, unfortunately. I hope this actually gets evolved a bit. If you do want to debug or set breakpoints, etc., you're basically going to be using a Flash Develop or IntelliJ for your external code editing. And then you can set Haxe breakpoints like normal. Debugging in Haxe have never been its really strong suit to start with. And then when you're ready to publish, just come on up here. So, for example, I have a Pro license right now thanks to the Humble Bundle. And you just click there. It's going to take a little bit of time. It's generating C++ code behind the scenes, etc. and compiling it now. So we'll let it just do its thing. And that's kind of it. The generated file isn't huge. I think it was about 4 megabytes. It's obviously going to depend on the amount of resources and assets you link in. But it doesn't create a bloated executable. There's no splash screen, nothing like that. The commercial aspects of Stencyl, the only thing there is basically to buy this desktop or mobile deployment options. If we go to, let's kick into it very quickly. Pricing. So for web and desktop deployment, you're looking at $99 a year. Published to iOS, Android, web, and desktop, you're looking at $200 a year. You can do full development, and pretty much everything you just saw here actually is available in the starter. But you're limited to just the Flash player deployment and publishing to the web. So if you want to do desktop deployment, you need to pay $100. If you want to do iOS, Android, and desktop deployment, it's $200. In my opinion, very reasonable rates. There's a lot included in there. So that's about it. That's Stencyl. I hope you enjoyed that. I hope that was useful. I'm impressed by it. Again, I think this is going to be, when someone comes up to me and says, I'm just getting started, I want to make games, what programming language should I use, or what tool should I get started with? I'm having a lot of trouble not recommending Stencyl. This just seems like the best fit, to be honest. And if you've got a quick, simple 2D game to make, even if you're a veteran, you saw the tools are all there. Everything you need is there. There's a couple of missing components, like the ability to set bounding volumes on a per-frame basis. But for the most part, it's an impressive 2D engine. Now, if you're not working in the 2D space, if your game is not scene-oriented, and you're not tile-based, this isn't the right fit for you. But for all other cases, I really strongly encourage you check out Stencyl and see if it works for you. I hope you enjoyed that. Thank you very much.